Imagine trying to read a dense textbook, but you also have to tap the desk exactly every 60 seconds. You find yourself constantly glancing back and forth between the page and a stopwatch. Because your brain is tied up just keeping track of the seconds, you aren't actually absorbing a single word you're reading. The act of counting takes up all your mental bandwidth. Computers face this exact same problem. If a microcontroller's main processor, the CPU, has to manually count milliseconds to time an event, it gets bogged down. We call this CPU load, and it stops the chip from running its main programs. The fix is a piece of hardware called an STM32 timer. You can think of it as an independent kitchen timer built straight into the computer chip. By handing the counting chore over to this dedicated hardware, the CPU is free to do the actual thinking and heavy lifting it was designed for. Every microcontroller has a built-in heartbeat, or a main clock, but it beats incredibly fast, often around 80 million times per second. That raw speed is great for complex math, but it's way too fast to be useful if you just want to do something simple, like blink a light or spin a motor at a steady pace. To manage this, the timer uses a prescaler, like a set of reduction gears on a bicycle. It takes those 80 million frantic ticks and mathematically divides them into a slow, manageable rhythm, like 1,000 ticks per second. Its job is to take chaotic machine speed and calm it down into a steady, reliable beat that the timer can actually use. So once the prescaler sets up that nice slow pulse, where does it go? It feeds directly into the counter. The counter is exactly what it sounds like. It functions just like the digital display on the face of a stopwatch. With every single pulse that comes out of the prescaler, the counter simply ticks upward. 0, 1, 2, 3. It just keeps a running tally. But right now, it's just blindly counting up. To be useful, the counter needs instructions on when to stop. A stopwatch is only helpful as an alarm if it actually knows your target time. That's where a piece of memory called the auto reload register comes in. This is the specific slot where the programmer punches in their target time. Say you set an auto reload target of 999. The counter continues to tick upward toward that target. The moment the counter matches 999, the alarm goes off. An event is triggered, and the counter instantly resets to 0 to start the next cycle. This diagram shows the complete path. The timer clock signal moves through the prescaler to slow down, to the counter, and is checked against the auto reload register. A match creates an update event, triggering an interrupt, the computer's kitchen timer ringing. That interrupt automatically taps the main CPU on the shoulder. It tells the processor it's time to pause for a microsecond, do a perfectly timed action like blink an LED, and then immediately go back to work. It brings us right back to our student. Instead of nervously checking a stopwatch, they are completely absorbed in their reading. When the physical kitchen timer rings, they smoothly handle it and immediately go straight back to the book. By handing off the time tracking to dedicated hardware, developers keep the main processor clear, letting the microcontroller juggle multiple complex tasks in sleep.